Okay, from a rectangular board, a carpenter cuts a stringer to support some stairs. This is the stringer, okay? Because it's supporting the stairs. Each stair rises 7.5 inches at a tread of 11 inches to the nearest degree. What angle should the carpenter cut? So, the carpenter needs to cut this angle here, yes? I'm going to zoom in to make it easier for your eyes to see. If the carpenter, needs to cut this angle, would it help to know this angle?
Yes.
Why? Sonia.
Because you can take that angle and minus it from the other one, because the whole thing would be 180.
Excellent. So if you know this angle right here, you're in business, yes? Mm-hmm. And is this angle right here not 7.5 and 11? Isn't it? So, that's our theta, right? We don't know what it is. Since we don't know theta, we're going to use shift tan, aren't we? And from that theta, we have an opposite of 7.5, and we have an adjacent of 11. So it's shift tan theta equals opposite 7.5 over 11. And when you do that math, what do you get? Don't be that way. What? 7? So 34 degrees, yes? Everybody happy with that? So what's the angle that I'm cutting? Because I don't want to cut the 32. 146. Yeah. And if you look in the answers, which I supplied for you, 146. Now, guys, this is what I mean by the difference between math and life. We did 2 calculations to figure that out, didn't we? Right? Were they difficult calculations? Yes. Of course, there's lots of ways you could have done it. What did you do?
I found, so that would be, I drew like at the bottom, yeah, like a line right down there, and then I did.
So you knew that was 90.
Yeah.
Yeah.
And then I drew a line across.
And you knew that was 7, this was 7.5, and this was 11.
And then I did.
Then you did.
So that was 56.
You did shift tan with that.
Yeah.
Yeah. Of course. Because you did the exact same thing. Now, the point I'm trying to make is, was this complicated math? Absolutely not. It was one calculation and a subtraction. Or if you did IS's way, it was one calculation and an addition. Doesn't make us brilliant, does it? But the carpenter that made that calculation was getting paid $45 an hour. Understand? If I give you this, 7.5, 11, and tell you to find me theta, great. That gets you really far where? Where in the world does that skill actually help you? Here. In this room. Anywhere else? No. What helps you everywhere else? Taking that skill and applying it to real life. If you can't do that, you're in trouble. And sadly for you guys, most of your math education has been just that and not actually applying it, which allows you to feel a false sense of security as you get closer to the end of school and we expect you to apply the math. Nobody has expected you to do that before. So you think that you're awesome. And you are awesome. But you got to be able to apply the stuff. Okay? Everybody understand? It's kind of like driving. It's real simple. Get in, turn the key, put the shifter into D, Push on the gas, we need to stop, push on the brake. Why does anybody have trouble driving? It's not hard. Vroom, thud, vroom. I have to turn right, turn the wheel to the right. I have to turn left, turn the wheel to the left. And yet, we can all drive go-karts, but put you on the road, we're in trouble. Yeah? Oh, and by the way, those of you that are beginning to learn to drive, try to learn to drive on a standard because they're about to disappear. Standard transmissions will be gone in your people's lifetime. They won't even exist. There's motorcycles without them now. That was like the last place that had to have them. Buses, semi-trucks, they're all going automatic. Oh, computer's frozen. Any other questions while we wait for my computer to unfreeze? It's cold out, so you know. Thank you, thank you. I'll be appearing here till the end of June. Tip your waitress. I even restarted it this morning so it wouldn't do this. You know how long it takes to restart this thing? It's like 7 minutes. I know. Thank goodness that I got a brand new computer. It's fresh out of the box. I'm going to designate one of you to have a stopwatch. And all time wasted by technology, we are going to add it up, and I'm going to send a bill to Microsoft. All right. Are we good? Shall we move on? CC? Or no? I'm going with CC. All right. Now, we are on page, I don't know, the next page. You guys are very smart young people. How many angles are in a triangle? 3. How many sides are to a triangle? How many sides have we dealt with? 2, which means we must need to be able to do something with the hypotenuse. As you found from your warm-up question today, if you don't know the opposite and the adjacent, you're a little bit hamstrung when it becomes time to work with the triangle. Fortunately, there's a way to take care of that, because tangent, as you can read right there, is not the only trig ratio. There are 2 others. Actually, there's 9 others, but you will only be dealing with 2 others this year. Those 2 others are sine and cosine, which on your calculator are sin, naughty, and cos. So if you look on your calculator, you may have been wondering yesterday, who are these buttons that are right beside tan? Well, now you know. They're sine and cosine. And they deal with different sides. Now, you guys are smart kids. If tan works with opposite and adjacent, and you need to work with the hypotenuse, then you must need something that works with the opposite in the hypotenuse and the adjacent in the hypotenuse. You're also smart kids in that you understand that the opposite and the adjacent switch places depending on what? Where you are in the calculator. What a dummy. Where you are in the triangle. Speaking of where you are in the universe, are you aware that it is now being debated by actual scientists, not just clowns, that we are indeed living in the Matrix? If you haven't seen The Matrix, that joke was lost on you, so I will translate it. We are indeed living in a computer simulation of a more advanced life form. That's why it's a debate, Shotzi. We don't know. Because the reasoning behind it is the amount of chaos that is the amount of unprecedented things happening in our universe right now seems to be too high to be explained by chaos theory. Every reaction in our universe tends towards chaos and disorder. It's a quantifiable curve. But what is going on our world right now is ahead of that curve. There are things happening that seem completely unpredictable and that shouldn't be happening. Like the Oscar envelope, like Donald Trump being elected. All of these things are things that are not predicted to be happening. It shouldn't have happened. And that is used by some of these debaters as evidence that there is bugs in the machine. And these same people are... No, because if... Shotzi, does my computer fix itself?
But the thing is, like, all the people that are in charge of the computer, they're like, oh, there's problems with this.
No, because it's a simulation. It's like when you have an ant colony. If you don't put enough food into it, the ants have to adapt. If we are indeed a simulation or an experiment run by a more advanced civilization, the whole point of that experiment is to see to what end we come. According to Elon Musk, the inventor of the Tesla, he believes there is a 1 in 10 billion chance that we are not living in a simulation, which means there is a 999,999,999% chance that we are. You can't. I listen to the radio. I don't watch YouTube. They took the red pill. Why would you want to? I agree with Cypher. Why not, Stanley? If this is the life with which you have, what if the real world sucks? What if no Earth exists? What if this is all we have?
And we think that the real life. Why do you do this? What if we're not actually living in Canada? What if we're living in like a different country and we're just like calling it Canada?
Okay, so like the sun's gonna consume us in like 2 billion years.
5 billion.
Yeah, 2.5 billion, whatever.
Could be tomorrow.
Yeah, probably. And like, okay, but if we're like one life form here, what's to say that there aren't life forms like?
That's why people believe this theory exists. If the universe, or indeed the multiverse, exists, the chances that we are the only civilization are infinitesimal.
Yeah, okay, but then why would we be the ones like being tested on? Yeah, why are we the ones like in the Matrix? Like, what if we're like, there's probably multiple.
Well, Shotzi, or Tavleen, I would argue that in our simulation, we have been given one world, and we are ruining it. Would you want to let us off this planet?
Wait, what happens if we completely reset button?
Probably.
Would you reset this?
Not yet.
Oh, not yet? A little bit more out of hand than ruining the one planet that we have? A little bit more out of hand than having half a population that is obese and half a population that is starving? A little more out of hand where we spend $500 million on Paul Blart Mall Cop?
Let's all just watch it. I was reading this thing on the radio. It's like the reason why most people are stressed is because you're on your phone too much.
Yes.
And it's like,
What?
you have to like disconnect for like at least a month. If I just turn that on.
Instead of God bringing Noah and the flood, that was like their way of trying to reset what we had already.
That was their Control-Alt-Delete?
Thing that they had
Like, this thing isn't working. It's frozen. Control-Alt-Delete. Restart. So, they deal with different sides than the tangent. And what is that different side? The hypotenuse.
How did we go back?
That's what makes you a grown-up. You're getting there. This is practice.
Do you want to see my phone background, Mr. Meyer?
Huh?
Yeah, so okay.
Yeah! Now you should send that anytime somebody texts you and you agree and you're cool with it. You send that picture. And then they're like, what? And you'll be like, don't worry about it. You don't get it. But then send it to a grown-up and they'll be like, that kid is the coolest kid I've ever met. All right. Try sending it to one of your grown-up friends and they'll be like, that's awesome. All right, here we go. The sine ratio. Sine compares the opposite. What does opposite mean in trig? Across the opposite side to the hypotenuse, which gives us this. Sine theta equals O opposite over hypotenuse. Smart kids, what must cosine be? Adjacent. Now, this is where it starts to get tricky because as Tavleen discussed in our warm-up, she called that hypotenuse the adjacent, yes? Because indeed it is beside the angle with which you are working. But it already had a name, the hypotenuse. So the adjacent, which is the, not across, the adjacent side, but not the hypotenuse, the adjacent side to the hypotenuse, which gives us this. Cos theta equals A over H, which then gives you this little mnemonic device, which is pronounced SOHCAHTOA. Now, when I was in the 10th grade and my grade 10 teacher gave me this, it was a different time in the world. And I said, oh, Mr. Stewart, that sounds like a Japanese word and like we're math ninjas. SOHCAHTOA! And Mr. Stewart laughed. Now, in 2017, when I make that joke, all of you do not laugh. You say, you racist. Just shows how much things have changed. Stanley, you are Japanese, are you not? Yes. Were you offended? Absolutely. As well you should have been. So anyway, I was a bit of a chump in grade 10. I thought I was a very funny guy. And by this time, we did SOHCAHTOA at the end of grade 10. And up until the end of grade 10, I was a math moron. A C minus was like, woohoo! I was so bad at math. So when we got to this, and I was like, oh, yet another new thing I'm not going to understand. Screw you, Mr. Stewart. Mr. Stewart was very handsome. My grade 10 girlfriend was madly in love with him. Every time I would leave his class, it would be like, how is Mr. Stewart? He's fine, Tamara. Anyway, he was a good-looking cat. Don't get me wrong. Much like your guys' grade 10 math teacher is a good-looking cat. It's just a thing with grade 10 math teachers, I guess. Anyways, yeah, so I was like, whatever, Mr. Stewart. And then when we actually did trig, I did understand it, and it actually made me understand all the rest of math, and it turned me from a C minus student into an A student, which is why I love trig. So let's do math. So this, SOHCAHTOA, it doesn't mean anything. It's just to remind you that sine works with opposite and hypotenuse. Cos works with adjacent and hypotenuse. And tan works with opposite and adjacent. Now you guys should have a nice big blank white space here in which you are going to draw what? A triangle, because you can't do trig without a triangle. And you're going to label that triangle in any way you wish. Don't you dare use a ruler to draw that triangle. Obsessive compulsive. Just draw one.
I mean, I have one.
90 degrees. And we are going to label this triangle with crazy letters. Letters that you would never guess that I would use. J, K, L. Ooh. Now you guys label the sides properly. What is the hypotenuse? Lil L or Lil. I had a girlfriend named Lil. I called her, her name was Lilith, and she wanted to be called Lil, so I called her Lil Ith. That really bugged her, because when we first started dating, I was still immature enough to think that if you bug the girl that you like, it will work.
Seems like you're a bit of a ladies' man in high school days.
I had my moments. This is little J, and this is little K. Right? Everybody cool? Okay, now I'm going to put me a red theta there, and I'm going to put me a blue theta there. Now, in reality, could I use theta for both of those unknown angles? In reality, would that be allowed? No, why not?
Because you have to at least know one of them.
Well, if I use the same symbol for two unknown things, they would be equal, wouldn't they? But I don't want to give you guys yet another Greek letter to mess with your heads. So I've used red theta and blue theta. Cool? All right. So for red theta, what is the tan, the sine? Actually, I'll do it in the same order of SOHCAHTOA. What is the sine, cos, and tan for red theta? Just the letters, because you don't have any numbers. What is the sine of red theta? Opposite over hypotenuse. What's opposite of red theta?
J.
Little j. What's the hypotenuse?
Little L.
Little l. What's the cos of red theta?
Little K.
Lil k over little l. And what's the tan of red theta?
Little J.
J
Little K.
over k, right? All right, now blue theta. What's the sine of blue theta? Really? Sine of little k over L. What's the cos of blue theta? You shouldn't even need to look now. J over L. And what is the tan of blue theta? K over J. That's trig. Please notice that when you changed positions, you changed fractions. Cos became sine became cos, and tan inverted or reciprocated. Everybody cool? Please remember that where you are in the triangle determines two of the three sides. Which two change? Which two changed? When we moved up to red theta, what changed? Or from red theta to blue theta? Opposite and adjacent. What didn't change? Hypotenuse is always the hypotenuse, no matter where you are in the triangle. Do I make myself clear? Yes? All right. So now you have all the tools you need to do all the trig you need. Do you think you follow different rules than what you do for tan? Of course not. So let's go back to our warm-up question. We now know, I'm going to erase all this, we now know we have this triangle. 90, 32, and this was 10, correct? And I wanted this side, right? So, if we were doing tan, we would do what Tavleen did. We'd write theta and O and A, yes? Right? Okay, we can't do that this time because tan doesn't work, but we follow the same rules. Do we have a theta? What is it? 32. What else do I have? I have an H of 10, and I need an O of... No. I know.
I mean, 10 is not the hypotenuse.
Yes, it is.
Yes, it is.
I'm so confused. I thought it was 9.
No. 8 squared is 64. 6...
O equals Y.
Okay. And the O is what?
Y.
Y. What uses O and H? Sine. So now we fill it in. Sine 32 equals O over H, Y over 10. How do I solve that? When it was tan, we just did multiply. It's going to do the same thing here, except what button are we going to hit instead of tan? Sine. So 10 sine 32 equals Y. Gouda? Great. And remember, the most difficult thing with trig is working with your calculator because all of your calculators are different. What do you need to hit at the end? Equals. If you don't hit equals, you don't have an answer. Make sure your answer makes sense. So let's go back to our notes, which we have right here. Let's start with this first one. What do I have for this first one?
Should I start this time? Oh well.
What do I have for the first one? Do I have a theta?
Yes.
What is it? 12. What else do I have? An hypotenuse of what? 25. And I need what? An opposite, which is x. What uses O and H? Sine. So it is sine 12 And listen to me, ladies and gentlemen, in your notes, I highly recommend you write down this next step until you are very good at trig. The next step, I am actually going to write it down as 25 sine 12 to equal x. And I'm going to assume that will reappear in a moment. I'll explain that in a moment.
Oh, I did it.
And the answer is 5.2. How to do that on a backwards calculator? On a forward calculator, it's 25 times sine 12 equals. On a backwards calculator, it's reversed. 12. You don't have to press times, but some calculators you do, Lauren. So, and if you press times, it won't mess you up. On a backwards calculator, it's 12 sine times 25 equals.
Or could it be 25 times 12?
It could be 25 times sine 12 as well. Or 25 times 12 sine equals. Or 25 times 12 sine equals. All of them will work. All the work seems to have disappeared. I don't know why. Well, I do know why, but I don't know why. Everybody good? I'm going to rewrite all that stuff that disappeared right now. Theta equaled 12. H equaled 25. O equaled X. And then sine 12 equaled X over 25. So 25 sine 12. Now, there's another reason to write this step. In math class, you get one triangle, yes? And you finish it and you're like, yay, gold star. In real life, you might need this more later, correct? So if you leave it as 25 sine 12, you can move it around to other places where you might need it. Do you understand what I am saying? And I will give you some examples of that soon.
For the general part of this unit, do you want decimals or do you not?
Decimals are needed only for lengths.
Okay.
So, let us go on to the next one, cabbages. What is my theta? 19. What else do I have? An adjacent of what? 40. What do I need? An hypotenuse of x. What uses A and H? Cos. So cos theta, oops, not theta, dummy head. Cos 19 equals adjacent 40 over hypotenuse. When the unknown is on the bottom, what do we do? Divide. So x equals 40 divided by cos 19. And again, you don't need to write that down, but it's a good habit to get into. Because as you go further and further in math, you will find less and less use for decimals, because all decimals, when your screen fills up, are a guess. Whereas this can be left in an equation as an exact number, much like pi. Cool? So your answer here is going to be 40 divided by cos 19, which? 42.3. Does that make sense? Yes, because you were finding the hypotenuse, and the hypotenuse must be the longest side, therefore it has to be longer than 40. And since this angle is small, that must mean this is small, so this can't be too much bigger than 40. Good? Now let's look at the last one, which is exactly the same as the previous four, because that's what trig is. Do we have a theta? No, we don't. X. What do I have? I have an adjacent of 13, and I have an hypotenuse of 22. So what uses A and H? Cos of x equals adjacent 13 over 22. Since I need an angle, what is it?
It's going to be cos dash 1.
Shift cos, right? So it's cos x of 13 over 22. And I find that on my calculator using shift cos. And what do I get? 54 degrees, because it's 53.7. Is everybody Gouda? Or are you Swiss? Swiss would mean you were full of holes in your understanding. I know, right? There are other cheeses that are full of holes. And not all Swiss cheeses are full of holes, ironically. For example, Emmental is not full of holes. And yet, it is indeed a Swiss cheese. Gruyere is not full of holes, and yet it indeed is a Swiss cheese. But the cheese we call Swiss cheese is often full of holes, but not always. Because the holes are, of course, air bubbles in the rotting milk. You know that's cheese, right? When I was in grade 12, some archaeologists in Britain dug up a 1,000-year-old piece of cheese. They found it in a village, and it was covered in like that much mold. They cut into the middle of it. The very middle was still cheese. I don't know if they ate it or not. Oh, please, like you've never cut the mold off your own cheese and eaten it. That's because you guys don't have to buy your own cheese. Wait till you're old. Cheese is expensive. That one little speck of mold on your giant block of cheese, I'm just going to cut that right off there. Oh, yum. Oh, yeah. You just wait, sister. When you pay $15 for a block of cheese of your hard-earned money, but then you pay $15 for a small block. You save money by buying in bulk. That's why you buy the big cheese, split it into tiny pieces, put it in your freezer. Of course you can freeze cheese. Freeze anything. I got friends that go buy milk in America in the gallons. They bring them home, put them in their freezer.
They freeze the milk and then.
All right, is everybody Gouda for grapes? Okay, go on to the next page, page 95. There, well, it's not page 95 in your books. It's page 95 as a title. The answers are there. You are doing 95 and 101, I believe. Yes. That is your homework right there.
I mean, each triangle below.
Answers are provided, but they are turned upside down.